Okay, class, we're starting on section 2.2, the multiplication property of equality. We have objectives 1 and 2. Use the multiplicative property of equality to solve equations. If A and B are expressions and C is a number, then the equation A equals B and A times C equals B times C are equivalent. That is, we can multiply each side of an equation by the same non-zero number without changing the solution. Example 1. We have x divided by 7 is equal to 9. Now we know in order to get the variable by itself, we would do the opposite operation of the number that's connected to the variable. The opposite of division is multiplication. So we will multiply each side by 7. Now we can make this 7 over 1, and these 7's will simplify out and leave us x. So x is equal to 9 times 7, which is 63. Now we go here to b. We have negative b is equal to 7. Remember, the number in front of a variable when you don't see it is a 1. So that's really a negative 1b is equal to 7. Now this negative 1 is connected to the b by multiplication. So we take its opposite operation, which is division. So we'll divide each side by negative 1. And you have positive b is equal to negative 7. Now we go down here to c. We have 5x is equal to 30. We need to get x by itself. So the 5 is connected to x by multiplication. So we take the opposite operation, which is division. We divide each side by 5, and we will have x is equal to 6. Now we go here to d. We have 28 is equal to negative 6x. Now we have to get rid of this negative 6 off of the x. And negative 6 is connected to x by multiplication, so we would divide each side. So now, on the right side, we will have x. On the left side, we will need to divide 28 and 6 by what they have in common. Both has 2 in common, so it would be a negative 14 thirds. Okay, now we scroll down here to E. Now we have negative 5.9n is equal to a negative 25.37. So we'll take negative 5.9n is equal to a negative 25.37. We divide each side by negative 5.9. And on the left side, we will have n is equal to. Now we have a negative divided by a negative, which is a positive. So we know n is equal to a positive 4.3. Now we go here to f. We need to get y by itself. But this 5, 6 is connected to the y by multiplication. Now what we could do to get rid of this 5, 6, we could multiply each side by the reciprocal, which is 6/5. Now these 6's will simplify out, and these 5's will simplify out, and you'll be left with y. Now here, we could multiply straight across. 3 times 6 is 18, and 8 times 5 is 40. Now what they have in common at 18 and 40 is 2. So we could divide your numerator and denominator by 2, and we will be left with y is equal to 9 over 20. Now, let's scroll down. We have objective 3. Use the addition and multiplication properties to solve equations. Now we scroll down here. We have 7x plus 2 equals 23. So what we would do here is we would subtract 2 on both sides. And we will have 7x is equal to 21. Now we divide each side by 7. And x is equal to 3. Now we go over here to b. Now if you notice b, we have a variable on both sides of the equal sign. So this is what we would do. We will first subtract 14 on both sides. We will have 6x is equal to 2x minus 16. Now we have to move this x to the left side. So we would subtract 2x on both sides of the equal sign. So now we will have 4x is equal to negative 16, and then divide each side by 4, and x equals negative 4. Now we scroll down to C. Now if you notice here on the left hand side, we have some like terms that we need to combine. We have 3x minus 5x, which is a negative 2x, minus 2 equals 6. Now we just need to get the variable by itself. So first we will add 2 on both sides, and we will have negative 2x is equal to 8. Then we will divide each side by negative 2, and x is negative 4. Now we go on to D here. We have variables on the same side like we had in the previous problem. So this time I want to move all the variables to the right side. So let's subtract 2w on both sides. So 2w minus 2w is 0, minus 9 is a negative 9. And that equals to 6w minus 2w is 4w plus 23. Now we need to get w by itself, so we will subtract 23 on both sides. Negative 9 minus 23 is a negative 32, and that equals 4w, because 23 minus 23 is 0. Now we have to get rid of the 4 off of the w, so we'll divide each side by 4. Negative 32 divided by 4 is a negative 8, and it equals w. Now we scroll down to objective 4. It says solve applied problems using formulas. Example 3. The data in the figure can be described by the mathematical model P equals 18n plus 765, where P is the puppy's price in years after 1940. So P is the puppy's price, and then the N stands for the years after 1940. If the trend shown by the formula continue, what will the price of a Westie puppy be in 2012? So what we will have here is P is equal to 18n plus 765. Now what we need to do is go off to the side here, because we want the years since 1940. So what we could do is take 2012 minus 1940. So 2 minus 0 is 2. We cannot subtract 4 from 1. We cannot borrow 1 from 0, so we'll borrow 1 from this 2. This 0 will become 10. We'll borrow 1 from that, and that will give us 9. And this 1 here will become 11. 11 minus 4 is 7. 9 minus 9 is 0, and 1 minus 1 is 0. So it's 72 years since 1940. So we have P is equal to 18 times 72 plus 765. Now we can go over here to the side and multiply 18 times 72. 2 times 8 is 16, carry a 1. 2 times 1 is 2, plus 1 is 3. We add our 0 here. 7 times 8 is 56. Bring down your 6, carry your 5. 7 times 1 is 7, plus 5 is 12. So we have 6, 9, 2, 1. So we have 1,296. So P is equal to 1,296 plus 765. Now, we will add these two values together. We could go off to the side. 1296 plus 765. 6 and 5 is 11. Bring down your 1, carry your 1. 1 plus 9 is 10, plus 6 is 16. 1 plus 2 is 3, plus 7 is 10. And we carry our 1, and 1 plus 1 is 2. So it'll be $2,061. And that will be the price. Okay, now we look at B. It says, what would be the price of a Westie puppy when it's 2,277? Okay. Oh, it says, when will the price of a Westie puppy be 2,277? So we will write the same formula. P is equal to 18n plus 765. But we would substitute in 2,277 for P, and is equal to 18N plus 765. Now we would subtract 765 on both sides. Now, 7 minus 5 is 2. 7 minus 6 is 1. We cannot subtract 7 from 2, so we borrow 1 from this 2. And this 2 here becomes 12. 12 minus 7 is 5. So this is 512 is equal to 18N. Now we would divide each side by 18. Now we can go off to the side here and take 18 into 512. 18 goes into 51. It goes into it twice. 2 times 18 is 36. We cannot subtract 6 from 1, so we'll borrow 1 from this 5 and make it a 4, and this 1 will become 11. So 11 minus 6 is 5, and 4 minus 3 is 1. And we bring down our 2. Now we have to take 18 into 152. Now we could use, let's see, 18 times 9 would be 162. So it'll be 8. So we had 8 times 8, which is 64. Carry a 6. 8 times 1 is 8 plus 6 is 14. So we cannot subtract 4 from 2. So we borrow 1 from this 5. So we have 4, and this 2 becomes 12. 12 minus 4 is 8. This is 4 minus 4 is 0. 1 minus 1 is 0. So we have 28, and we could do a decimal. And let's see if we need to round up the year. 18 goes into 80. Let's see. 18 goes into 80. Looks like 4 times. So it'd be 4 times 18, which is 72. And we have a repeating 4. So it says, when will the price of a Westie puppy be? 2,277. Now it would be about 1968. The price of a Westie puppy will be $2,277. Now remember, it's the year since 1940. So since we have 28.4, we know we would not round the 28 up to 29 because this should have been like 28.5. So we would add 28 to 1940, and that gave us 1968. So it's about 1968 because we know it's in part. It's not exactly the middle, but it's close to the middle of the year that it will get to $2,277. Okay, now that is it from section 2.2.